So in this presentation, we are going to see parametric and nonparametric machine learning algorithms. So we already know there are two types of machine learning. That is, one is supervised and another one is unsupervised. So that is a type of machine learning. But in this class, we are going to see what are the types of machine learning algorithms. There are two types of machine learning algorithm. The first one is non-parametric. Okay, let me start with parametric machine learning algorithm. So what is that? So parametric in the sense parameters. So when we train a model and if we give the training data with a fixed number of parameters, we call that as a parametric model. I repeat, that is when we train a model with the training data and if the data set has a fixed number of parameters, we call that as a parametric model, and that number of parameters that is going to be used does not depend on the size of the data set. Even if the size of the data set is getting increased, if 2 parameters is going to be used to train the model, the number of parameters used is only 2, and if the size is less, the number will not be changed, which is called as parametric. The second step is the coefficient. So by after creating the formulas, we are going to learn the coefficient by. Okay, so we take this example. So here the form that we have used is b0 plus b1 into x1 plus b2 into x3 is equal to 0. This is the form that we have selected for the linear regression. Okay, so here the mapping function that we have used, you can easily see it is in the form of y is equal to mx plus c, which is a line function. Okay, so here this is going to be a line function. So where b0, b1, b2 be a coefficient and x1, x2 be a. Okay, so here are some example for parametric machine learning algorithm. The first one is logistic regression. The second one is linear discriminant analysis, perceptron, navy Bayes, and simple neural networks. So we will be learning about simple neural networks in the 5th unit and logistic regressions in the second unit and perceptron, navy Bayes in the 3rd unit. Okay, so what are the advantages of parametric machine learning algorithm? So since our parameter is going to be a fixed one, fashion, it is very simple. Okay, so we can easily understand the model and we can easily interpret the results, and we can interpret the results directly for the conclusion. Okay, the second one is speed. So since it is very simple, automatically the speed is also going to be very high. So it is very easy and fast to learn from the data and less data. They do not require as much training data and can work well even if the fit data is not perfect. Then what are the disadvantages of this parametric machine learning algorithm? The first one is constraint. So here our parameter is going to be completely a fixed one. So it is a it has a constraint. After that, if our data set is getting increased, we cannot increase the parameters once it is trained. The second one is limited complexity. That is, it is purely depend on the complexity of the problem. That is, it works well only if the problem is a simple problem. If the problem is a complex problem, for sure it is we should not choose this parametric machine learning algorithm. The third disadvantage is a poor fit. Okay, in practice, the methods are unlikely to match the underlying. Okay, so the next type is non-parametric method. So if the parametric method is a fixed number of parameters, for sure it is not a fixed one. Dynamically, the number of parameters can be changed, depends on the size of the data, the size of the training data. Okay, so here lot of data. If we are having a lot of data, the number of parameters that we are going to choose, for the choosing the number of parameters, there is no need of having the prior knowledge about the data. So we no need to worry about whether we are extracting the correct features, whether we are selecting the number of parameters is very right. So we no need to worry about this in the algorithm. Okay. The advantage of this non-parametric algorithm is that is here depends on the problem, depends on the complexity of the problem. We can increase the number of parameters. That is the first advantage, and we no need to worry about the size of the data, and we no need to worry about the form of the data. Okay. So what these are the examples about a non-parametric machine learning algorithm. The first one is k nearest neighbors algorithm. The second one is decision trees, and the third one is support vector machines. Okay, so here at this time there is no need to learn about these things. Okay, so what are the advantage here? As I said, it's a flexible one, and its performance is very good performance, and power here it works. That is here no assumptions, there is no assumptions, or so we no need to worry about whether it is a weaker assumption or not. So this is the first, and the limitation. So here for choosing the number of parameters, it means lot of training. So because once it is trained lot, then only it will be very easy to estimate the mapping function. And since here for each and every iteration that is it has to be trained for choosing the number of parameters itself, so it is very slower. So, and one more thing is it is a overfitting. So whenever we choose the number of parameters as high, it will cause the overfitting problem. As we know, overfitting problem is, so if our best fit line, that our model's best fit line suits all the fits all the training data, and if it is not fitting for the testing data, it causes the overfitting problem.